So the next question is, what do we do whenever we want to factor like really, really ugly polynomials, like polynomials only a mother could love? This is one of them. It is yucky, it is icky sticky, scary polynomial. Ah, I don't want to do this. So first thing I do when I see this on a test is I cry. And then I remember that like I want to, be famous and rich, and to do that I have to be good at math. So there's got to be a way through. First thing I'm going to do is I'm going to desperately look for stuff that they have in common. So I think, all right, well, maybe I could pull out a 3 because this is a 4 and a 3, but this stupid thing is prime. This is a prime number, well, at least a 13 is, so that means that there's probably nothing that I could take out. It'd be really amazing if I could pull like a number out of this, but it doesn't look like it can. So since I can't pull any numbers out, the next thing I'm going to look at for is other stuff to pull out. So they all have an A in them, which is actually kind of nice because that means I can pull an A out. So I go A, and if I pull out an A, I have left 12. I take an A out of the 8 to the 5th, that leaves me with an A to the 4th. Then I go with 157, A squared, then B squared, then 13, B to the 4th. Woohoo! It doesn't really actually look that much more impressive, but I think that's about all I've gonna get, which is kind of sad. Now what I'm going to do is, because I've done this before and I kind of know what to do, I'm going to pretend that these aren't here. Well, that's a bad way to say it. So, kind of what I see is that this is a b squared, and this is a b to the 4th, okay? Which is kind of like seeing a polynomial backwards, right? Because in a normal polynomial, you have like blah x plus blah, or blah x squared plus blah, plus a number without an x on it. And so we kind of have that, because that's a 4th term, and that's a squared term, and then there's not a b. There's no b term there. Well, to make a long story short, that basically means that I'm going to have b's, well, in my answer at the back, but not in the front. And I have a's in the front, but not in the back. Okay? I have a's in the front, but not in the back, b's in the back, but not in the front. So that means that whenever I'm factoring this thing, whatever it turns out to be, so I have an A, it's a trinomial, so I'm assuming it's something like this. I'm going to have A's up here at the front, and I'm going to have B's over here at the back. Now, my B's at the back, whenever I multiply them together, there you go. When I have the B's at the back, when I multiply them together, whenever I do this multiplication thingy, I need to get a B to the 4th. And the only way to make that happen, well, not the only way, but I'm going to say the easiest way for me right now to assume that's going to happen is to make them both b squared. Because if I go b squared times b squared, I get a b to the 4th. And that makes me a happy panda. Then in the front, when I multiply the two front ones together, I should get an a to the 4th. And the best way to make that happen is to have a squared and a squared. So I have a squared times a squared is a to the 4th. And I have b squared times b squared is b to the 4th. So I'm like getting partial credit or something. Now, I know I did this right because, because if I do my inner terms, inner term gives me a squared b squared, and the outer term gives me a squared b squared, which is my middle term there. So I've actually got those right. So that's fun. So really what I need to do at this point is figure out what kind of coefficients need to go in front of these squares. Now, hopefully you're not attacking these problems without a basic idea of the FOIL method and how to factor stuff and whatever. So right now we're kind of assuming if I gave you a problem that looked like, x squared plus 4x plus 3, that hopefully you could, do that. Because if you can't do this, you can't do that. So don't even try this problem here until you're really, really, really good at that problem. And you kind of got to be really, really good at that problem to get good at, like, other problems. So, like, once you get good at doing those kind of problems, then hopefully you can get it going at a problem like this one, which, in case you care, is, well, how about we look at that for a second. So whenever I'm doing a problem like this, I've got to break this out, and I remember, okay, well, these are both pluses, so that means that's going to be a plus here. This is going to be a little x here and a little x here. And I go, okay, well, what are my various factors of 3s and 6s? And then I play around with it eventually, and I get 3x plus 1 and 2x plus 3. And if I, FOIL that out, multiply that out, then I'm, good to go. I've got the first ones multiply together to get 6x squared, the middle ones are 2x, the outer ones are 9x, and the last ones are 3. So when I add them together, I get that. Okay, so if this is not good, you're not doing this one here. You gotta have, this has to be a happy face in order to do this problem here. Okay, so that said, let's go back and look at the problem that we got in front of us. So I see I have two plus signs here. So everything's going to be a beautiful plus sign. It makes me happy. Okay, now I need to find two numbers that multiply together to make 13. Luckily, there's only two of them. There's a 1 and a 13. So 1 and 13. Those are the numbers. It doesn't really matter what order I put them in because they're all plus signs and I'm good to go. Now, over here for the 12, I've got to figure that out. So I've got a lot of options for the 12. I've got 1 and 12. I've got 4 and 3, and I've got 2 and 6, and I'm just going to have to mess with this until I actually figure it out. So I'm going to start off, I'm going to go 1 and 12. If I multiply that out, I've still got the 12 in the front, which is good. If I do inner and outer, my outer gives me 13a squared b squared. My inner gives me 12a squared b squared. That adds up to 26e squared b squared, which is nowhere near the 157 I need, so that's... Alright, so what I can do now is I can switch them. What if I do 12 and then I do 1? So if I multiply the ones on the outside, I get 12 times 13, and who in the name of anybody knows what that is? 1, 2, wait, can I not add? No, 3 plus 2 is not 6. It is officially 5. So when I do the outside ones, I've got 156a squared plus b squared. And the inner ones, I've got 1 times 1 is 1, yay! I can do that one. So when I add those, I get 157, which is phenomenally and blessedly and amazingly the 157 that I need. So actually, whenever I look at this and I try to rewrite it because I want to make it pretty, and then like look at it later and go, look what I did! I'm going to show all my friends and they'll be so impressed because they get to know me and I'm such genius. And let's see. So I've got this here, and I'm going to look at it. And I'm going to really, really hope that I can't factor anymore because, quite frankly, my factor skills I'm tired. So look, it's beautiful, and I can pat myself on the back for being phenomenal and make smiley face. So hopefully that's helpful to you.